Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right, let's have a look at the 2013 question. It was question 9 on that paper 1, so another longer question, a 50 marker one again. Shapes in the form of small equilateral triangles can be made using matchsticks of equal length. These shapes can be put together into patterns. The beginning of a sequence of these patterns is shown below. So pattern 1 has 3 matchsticks. Pattern 2 has 1 triangle and then 3 triangles on the bottom. 3, we add on another row. Okay, part 1, draw the 4th pattern in the sequence. Okay, so let me try and draw this now. So that's 1, 2, 3. Okay, so now I need to add on my own row. Okay. Some love these, some don't like drawing them at all. I'm not a particularly great drawer, so I don't like them. But anyway, there it is. It is a nice, handy question again, just like filling out a table. So we'll take that. The next part then says, the table below shows the number of small triangles in each pattern and the number of matchsticks needed to create the pattern. Complete the table. Okay, so let's have a look, and it's pattern 1, 2, 3, and 4. So we've drawn all 4. Number of small triangles, there's 1 in the first one. In the second one, there's 1, 2, 3, 4. In the third one, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and they've that filled in. And then in the fourth one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 in the last one. Okay, then the number of matchsticks, there was 3 in that one. There was 1, 2, 3, 4, 5, 6, 7, 8, 9 in the second one. In the third one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 in the next one. And then in the fourth pattern, 1, 2, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Right, so those 2 parts were fine. Nothing too bad about them. Okay, and then B, write an expression in N for the number of triangles. Okay, so it's this one here we're looking at. We just have to be careful in this question as to whether it's the number of triangles they're talking about or the number of matchsticks, okay? Because there's 2 distinct different sequences going on here. So write an expression in N for the number of triangles in the nth pattern. Okay, so there's 2 ways you can tackle these type of questions. You can see the pattern, and some people are really, really good at seeing the pattern. Or you can develop the TN term. Okay, so what do I mean by that? Well, if I see the pattern, if I can call it that, okay. Okay, so you write down the terms. So basically, N is 1 here, N is 2 here, N is 3 here, N is 4 here, okay? And then you write down how many triangles are in it, okay? So this would be the number of triangles. So I have 1 triangle here, I have 4 triangles here, I have 9 here, and I have 16 here, okay? And what you're doing is you're comparing the n value with your answers, and you're trying to establish if there's a pattern between what the n value is and what number of triangles you get, okay? And if you can see it in this case, you can see that if you square your n number, you end up getting the number of triangles. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and of course n is equal to 5 will be 25, okay? So then you can simply write down that Tn then is equal to n squared, okay? And you get full marks for that, okay? Let me write it up here where we have our solution, okay? Now, not everyone is that lucky that they can see the pattern, okay? So if you can't see it, then you are looking at the pattern as such, and you're working with formulas, okay? So it's whichever way you see it. Okay, so second difference is the same, therefore quadratic. Tn is equal to an squared plus bn plus c, okay? And we know that a, our first term, is equal to, 2a is equal to the second difference. So 2a is equal to 2, or a is equal to 1, okay? So therefore we have Tn being equal to n squared plus bn plus c. Okay, because we've now substituted in a here to be 1. Okay, so that's where the a has disappeared to. And then, just like we were doing in the last class, we will set up 2 simultaneous equations. So anyone who missed that class, that was Wednesday's class, go back and have a little look and just see. We did these probably a lot more slowly than we'll do it now. So for our first term, we let n equal to 1. And of course, you have to let it equal to the value that your first term is, okay? So I'll end up with b plus c here equal to 1 minus 1. b plus c is equal to 0. Okay, so that would be my first equation. Oh, sorry. Okay, and then we'll set up one using T2 so that we have 2 squared plus b times 2 plus c, and of course it has to be equal to what my second term is. So 4 plus 2b plus c is equal to 4. So of course I'm going to get 2b plus c being equal to 0 again. Okay, let me add in a page just so we can solve the simultaneous equations. I have b plus c equals 0, and I have 2b plus c equal to 0 if I remember right. Okay, let's put a line under them. Let's change the sign, So I have b being equal to 0 here. Okay, and now that I have b equal to 0, let's go back and sub in. And I also get c being equal to 0. Okay, so what you do then is you take your Tn equation that you've set up. We had n squared plus bn plus c. We sub in the 2 values we just got, which is 0 for b, 0 for c, and you get Tn being equal to n squared. Okay, so you'll get at your Tn equal to n squared whether you see it from the pattern or from the equation, okay? And you don't get more marks for either way, it's whichever you see. Okay, part C then says find an expression in n for the number of matchsticks this time needed to turn the n minus 1th pattern into the nth pattern. Okay, so how do we do this one then? Okay, again, you can see it. Okay, you can number of matchsticks 3, 9, 18, 30. So I have 3, 9, 18, 30. So n is equal to 1 here, n is equal to 2, n is equal to 3, n is equal to 4. okay? And basically you are trying to figure out, well, if how many matchsticks am I needed? There's a difference of 6 there, there's a difference of 9 there, there's a difference of 12 there. Okay, so as I travel up through the ends, how many more matchsticks are needed? Okay, but to go from 1 to 2, I need 6 more. To go from 2 to 3, I need 9 more. To go from 3 to 4, I need 12 more. So what is the link then between 2 and 6? 3 and I need 9, and 4 and I need 12. Okay, so can you see that there's a multiply by 3 going on in each of these? Okay, so therefore your answer will be 3 times n. That's how many more matchsticks you needed to go from one to the other. Okay, so again, full marks if you can see it. Let's not worry about it if you can't. 3, 6, no, sorry, 3, 9, 18, 30. Let's have a look at the difference, the difference, the difference, the difference, the difference. Okay, so again, we're looking at a quadratic sequence. Okay, 2a is equal to 3, a is equal to 1.5 or 3 over 2, whatever way you want to write it. Okay, so therefore our Tn is equal to 3 over 2 or 1.5, whichever you wanted, plus Bn plus C. Let's take the first one. We get 3 over 2 by 1 squared plus b times 1 plus c, and of course that must be equal to my first term. So 1 squared, so I'm going to get b plus c being equal to 3 minus 3 over 2, or b plus c is equal to 3 over 2, okay, or 1.5. Okay, so that would be my first equation. I'm going to go onto a new page rather than squish. So for my second one, I have 3 over 2 n squared plus bn plus c equal to, my second term is 9. Okay, I need my calculator now for him. 3 over 2 by 4. So I have 6 plus 2b plus c being equal to 9, or 2b plus c being equal to 3. Okay, and that's my second equation. So let's bring our equations together again. So b plus c is equal to 1.5. 2b plus c is equal to 3. Let's cancel the c's. 2b minus b is equal to 1.5 or 3 over 2, whichever you prefer. Then let's sub into here. B plus c is equal to 1.5. So c is equal to 0. Okay, so let's put him back in. So Tn is equal to 3 over 2 plus Bn plus c. So it's equal to 3 over 2, sorry, that should be in n squared plus 3 over 2n plus 0. Okay, so that's my nth formula. Okay, now remember I'm looking for the difference. So it's how many matches do I need to turn the n minus 1 pattern into the nth pattern. Okay, so I need an expression for n minus 1. Okay, so what you do is you, instead of everywhere you see n, you put in your n minus 1. That's how you develop a formula for the nth minus 1 pattern. And it will be the same for the nth plus 1. If the question called for that, you just replace n with n plus 1. Okay, and let's work him out. So I have to do the square bit first because of BOMDAS, okay, and then I multiply by 3 over 2. So n squared minus 2n plus 1 plus 3 over 2n minus 3 over 2. So it's 3 over 2n squared minus, the 2's will cancel, 3n plus 3 over 2 plus 3 over 2n minus 3 over 2. Let's see if we can tidy this up a bit. So 3 over 2n squared minus 3 over 2n, okay? Minus 3 plus 3 over 2 leaves 1.5 again. Okay, so that's what I'm getting for Tn minus 1. Okay, I need another page. So therefore, I am seeing, well, what is the difference? So Tn minus the one before it, okay? So for Tn, we had 3 over 2n squared, 3 over 2n squared plus 3 over 2n minus 3 over 2n squared minus 3 over 2n, okay? And you can see anytime I have a minus in the middle, by default, I will put brackets there because that minus, I have to ripple through everything. It's going to change the sign of everything coming after it, okay? So don't make the mistake of making this one minus, but forgetting to do minus minus here. Okay, if you're in danger of doing that, put in the bracket like I just did there and it'll stop you doing it. Okay, so I just rippled through that minus here, and then minus gave me a plus. My n squares are cancelling, and 3 over 2n, I took shortcuts all over the place. 3 over 2n plus 3 over 2n is 1.5 and 1.5, so it's equal to 3n. Okay, so much longer, but you'll get at the same answer. Okay, if you can spot it, lucky you, that is super, but not everybody will spot it. Okay, the number of matchsticks in the nth pattern in this sequence can be represented by the function un is equal to ab is equal to un is equal to an squared plus bn, where a and b is an element of q and n is an element of n. Find the value of a and the value of b. Okay, so this might throw you in a way because we've just done it. So we have literally just found the formula for the number of matchsticks in the nth pattern, of course, because that's Tn. So do you remember we got 3 over 2 n squared plus 3 over 2n, if I remember right. Okay, I'm taking it from here. Okay, so what you do is you say from before, okay, and that tells the examiner I worked it out in the previous question, and now you write down a is equal to 3 over 2, b is equal to 3 over 2, and in fact you're done. Okay, so you might be cross at yourself that you didn't see the shortcut way when you were doing this question, but no matter, you got rewarded for it here anyway. Okay, and there was another part. One of the patterns in the sequence has 4, 1, 4, 2 matchsticks. How many small triangles are in that pattern? One of the patterns in the sequence, the number of matchsticks, okay? So we had Tn was equal to, this gave me the number of matchsticks, 3 over 2 n squared plus 3 over 2n. Okay, and I'm wondering when is that equal to 4, 1, 3, 4 matchsticks? Okay, well, let's multiply across by the 2. Let's bring across that number. I'm going to see, can I divide across by 3? So does 8, 2, 6, 8. Can I divide that by 3 and get a whole number? I can. Not, but I'm still going to use the minus b formula, so it doesn't really matter. Okay, I suppose it just makes the numbers easier in the minus b formula. Okay, but again, no big deal if you didn't multiply across by if you didn't divide across by 3. b squared minus 4ac all over 2a. We hit the square root sign, so 1 squared, or 1 minus 4 times minus 2756. So I'm getting n being equal to -1 plus or minus 105 over 2. Let's split it. So I'm going to hit the fraction button, -1 minus 105 all over 2. And I know when I'm working this one out that I'm going to get the negative number, guys, but as you can see, I tend to do it anyway, just for completion in the question, okay? So I now know that the pattern or the term n is equal to 52 has 4, 1, 3, 4 matchsticks. Now, unfortunately, it didn't ask me which term. It says how many small triangles in that pattern. Okay, so when n is equal to 52, did we have a formula for the number of triangles? It was n squared, wasn't it? Yeah, so it was n squared. So the number of triangles is equal to n squared. So 52 squared is equal to 2704 triangles.
If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.